Hi, my name is Amy Norgaard, and today I will be presenting my research on the trade-offs in organic nutrient management strategies across mixed vegetable farms here in Southwest British Columbia. So organic agriculture is was a $5.4 billion market in Canada in 2017. However, yields on organic farms are still typically lower compared to conventional, and this is largely due to challenges with nutrient management, and specifically with nitrogen availability on organic farms. Echoing this, organic farmers also rank nutrient management as a research priority. And so for my research, I specifically looked at nitrogen and phosphorus. And the reason for this is because of the environmental impacts associated with these two nutrients. So specifically for nitrogen, here in our province, we're phasing in mandatory post-harvest soil testing, and that's specifically soil testing for post-harvest nitrates. And then also in a 2012 soil nutrient study here in the Fraser Valley, researchers also found that 94% of fields that they tested had high or very high available phosphorus. So our fields here generally have quite high soil phosphorus, and this isn't a local problem. This is found across North America and Europe. Basically, wherever there's a livestock industry and phosphorus is being imported, then local soils tend to have high soil phosphorus. And the reason this is linked to organic farming or farms that are using organic nutrient management strategies is because of the use of compost. So specifically, compost has nitrogen and phosphorus is coupled in these products or in these amendments. So when we apply them, obviously in the scenario showed on the left is worst case scenario where we're applying compost or amendments at a rate that's much beyond crop requirements. And so this is obviously an inefficient use of nutrients. We can reduce our compost applications to just meet crop nitrogen demand. However, if you, due to the mismatch of the ratio of these nutrients in the compost or these manure-based amendments, we're generally still over-fertilizing for crop phosphorus. And so then we can reduce our compost applications to a lower compost application rate to meet but not exceed our crop phosphorus requirements, but then obviously we'd come up short in terms of meeting crop nitrogen requirements. And one solution to overcome this is to use specialty organic fertilizers such as feather meal or blood meal or alfalfa meal. Basically, these organic fertilizers that are high in nitrogen but bring little to none extra phosphorus into our farm fields. So this is the basis for the 3 nutrient management strategies that I was trialing in these field trials. So the first nutrient management strategy we called high compost. So in terms of the nutrient source that was being used, it was just a high rate of compost application targeting crop nitrogen demand. There was no fertilizer being applied, and the theoretical outcomes here are that for nitrogen, it would be meeting crop nitrogen requirements, but for phosphorus, it's exceeding crop phosphorus requirements. The second strategy that I trialed in this study was we called low compost plus nitrogen. This is applying compost at a much lower rate to target crop phosphorus requirements, and then topping up the crop nitrogen requirements with that feather meal nitrogen fertilizer. The theoretical outcomes here are that we're meeting crop nitrogen demands and also meeting crop phosphorus demands. The third nutrient strategy that I also quantified for this research project is just we called it typical, and it's just the usual nutrient application for a given crop on each farm. And the outcomes here, they were unknown at the start of this project. So briefly, the 2 objectives for this project, the first one being to evaluate these nutrient strategy in terms of these 4 outcome areas. So the first one is productivity, measured as yield. Second is impacts to soil carbon. So that was measured as permanganate oxidizable carbon, or P.Ag as we all call it. And then the third is these impacts to the environment. And so that's measuring post-season available nitrogen and post-season available phosphorus. And then also an indicator of economics, which we just looked at input costs. The second objective is to understand the variation in these nutrient strategies outcomes, and so specifically to identify the edaphic, environmental, and input quality factors that best explain the variation in my objective 1 outcomes. So just briefly, the field methods that were used for these field trials, which we carried out over 2 years, so in 2018 and 2019, and we worked with 20 different organic mixed vegetable farms here in Southwest British Columbia. So here's the province, and we just worked with just in this little subset down here in the southwest corner. So in these 3 different regions, so the Pemberton Valley, the Fraser Valley here on the coast, and across Vancouver Island. Just quickly, introduction to these regions. So in terms of climate, the Pemberton Valley being more continental, whereas the Fraser Valley and Vancouver Island having more moderate oceanic climates. And then the soils, the Pemberton Valley and the Fraser Valley generally have finer textured soils, largely glacials with some regosols also being found in the Pemberton Valley. And then out on Vancouver Island, much more variable textures found there, from fine texture to medium textured soils, and largely glacials and brunosols. So in my project, I generally had these 4 different sampling points, so preseason, midseason, harvest, and postseason. My preseason sampling took place in April or May, and this was going out and sampling baseline compost and soil properties, and then also gathering target yield information from the farmers. And then I took this information back and I performed some calculations, and specifically using the plant available nitrogen, or PAN, and the total phosphorus content of the compost, and then also using the crop nitrogen requirements, or PAN requirements, and phosphorus requirements, and then combining these two to inform an amendment application rate, or how much compost and feather meal fertilizer to apply. So then we took this information, went out to the field, and we applied lots of compost, whether by hand or having tractors spread it to quantify that typical application. And then mid-season came around, and we'd be back out in the fields in July, and this was sampling at the 0 to 15 centimeter depth, and these samples were analyzed for permanganate oxidizable carbon, or P.Ag. And then third, I'd be in the field again for harvest, and so this took place in July through September, and I was harvesting for yield measurements, and specifically the crops that were common in this research were carrots, beets, and potatoes, as well as there were some farms that grew cauliflower, broccoli, kohlrabi, cabbage, and cucumber. And lastly, my postseason sampling took place in September and October, and this was measuring for available nitrogen at both depths, so 0 to 15 and 15 to 30, and then also measuring just the more shallow depth, 0 to 15, for available phosphorus, and that was specifically using the clone extraction, which is a good measurement for our soils here in British Columbia. So the key findings in terms of these 2 objectives that I've highlighted. So first, in terms of yield, I did not find differences across regions and years in like the whole data set. However, there were interactions in the mixed effects model that I was using, and so drilling further down into that data set, in terms of yield, I did find yield differences just in the Fraser Valley, and specifically just in 2019. So here we have a box plot diagram with crop yield on the y-axis, and we have both years on the x-axis, so 2018 and 2019. Each of these colored box plots indicates a nutrient management strategy, so we have high compost, low compost, and typical. And as you can see, in the Fraser Valley in 2019, the high compost plots did have higher yields than the typical plots, and neither of those were different than the low compost plots. In terms of input costs, again, no broad differences between nutrient management strategies, but within regions. So here we have input costs on the y-axis, regions down here across the x-axis, and in the Fraser Valley, we did find higher input costs associated with the high compost plots and the low compost plots compared to the typical plots. Neither of the other regions had differences within them for input costs. For P.Ag, I did not find differences across the nutrient strategies, which was surprising given that there was a substantially greater amount of carbon being applied to those high compost plots versus those low compost plots. However, as expected, in terms of postseason phosphorus, we did find higher postseason phosphorus in our high compost plots compared to our low compost plots. Not surprising, and neither of those plots were different than the typical. In terms of post-harvest nitrates, I didn't find any differences in post-harvest nitrates in either of the depths, the 0 to 15 or the 15 to 30. However, this isn't because there was low post-harvest nitrates across the board. I did find some plots that did have higher post-harvest nitrates, and that's in comparison to this red line here indicates the post-harvest nitrate levels that are being regulated now or stipulated by the current regulations that are being phased in our province. And so then to answer a second objective and kind of ask the question, what is it about the farm in terms of these baseline soil properties or compost used at each farm, like what of those properties drove post-harvest nitrates in each of these plots, if it wasn't based on nutrient management strategies specifically. And so to understand how post-harvest nitrates in the 0 to 30 centimeter depth coordinate with baseline soil and compost characteristics at each farm, I performed a principal component analysis, or PCA, on the 10 compost and soil variables that are shown here on the left, along with the post-harvest nitrates in the 0 to 30 centimeter depth within each of the plots. And so for those of you who are unfamiliar with PCA, this is basically a way to see how multiple variables co-vary. And in this case, we did find that the post-harvest nitrates in the high compost plots did coordinate with composts that were high in total nitrogen as well. So to conclude or bring this back to my original objective, so answering that first objective question, what are the trade-offs in these nutrient management strategies measured across these outcome areas? So as you can see, there weren't clear trade-offs, even though we were expecting some. In terms of P.Ag, it was surprising that reduced compost applications didn't impact P.Ag, and although this was a short-term study, we did expect to see that. And then however, it wasn't surprising that available phosphorus changed in just these 1 or 2 seasons of reduced compost applications. And so this is specifically across all of the regions. However, for the Fraser Valley, we did find a few of those trade-offs, and that was specifically where farms are more similar. And then looking at that, so what influenced nutrient strategy performance? Well, in the Fraser Valley, where farms are more similar and a lot of them are using high nutrient composts and oftentimes lower cost composts, we did see that high soil phosphorus as we saw in all the regions, but we also found higher yields in the high compost plots when there was a fair amount of nitrogen being applied. And then in terms of input costs, we did find though that the typical plots were less expensive than our high compost and low compost plots. And then also our PCA showed that our postseason nitrogen was higher in the high compost plots when high nitrogen content composts were being used. However, the variation in management, such as soil compost, were stronger influences on outcomes in the nutrient management strategies themselves. And future research should definitely look at longer term evaluation of impacts to soil organic carbon, and also looking at other sources of carbon such as cover crops, which can also supply nitrogen and capture nitrogen, and then should also include a more substantial economic analysis, such as including labor, crop quality, and cost of compost tests, etc. Thank you for your time.